Hello folks, we come to the part 6 video of this miscellaneous exercise, and let's see how we can get this solved. We are having this question number 15, which gives us a set A which is having elements minus 1, 0, 1, 2, and the set B which has got elements minus 4, minus 2, 0 and 2. They are defining two functions f of x and g of x. They are asking us to show if they are equal on these sets. So what we will do is we'll find out the function f, we will find out the function g, and then we'll see if they are equal or not. So let's find out this function f. If we can make a partition like this, let's find out here. Let's first find out f is defined on this first. So f of minus 1. What is it? Minus 1 squared minus 1. So that's 1. No. Minus 1 squared minus of minus 1. So 1 plus 1, it's 2. F of next is 0. So it is 0 minus 0, 0. Next is 1. So it is 1 squared minus 1, that is 1 minus 1, 0. Then it is 2. 2. So that is f of 2 is 2 squared minus 2 by definition. So that's 4 minus 2, 2. So you have got the function f like this. If you want, you can write it like this, that it is minus 1, 2, 0, 0, then 1, 0, and 2, 2. Okay, so also we'll see g of minus 1. So it is 2 modulus of minus 1 minus half minus 1. So this is minus 3 by 2. So when we take the modulus, it will be 3 by 2. So it will be 2 into 3 by 2 minus 1. 3 minus 1, it's 2. Then g of 0. So it is 2, 0 minus half minus 1. 0 minus half means minus half. So it will become half when we take the modulus. So it will be then 1 minus 1, 0. Then we'll take g of 1. So it will be 2, 1 minus half minus 1. So this is half. And when we take the modulus also, it will be half. So 2 and 2 can cancel. 1 minus 1 will become 0. Then we have g of 2. G of 2 means 2 minus half minus 1. So 2 into 3 by 2. 2 into 3 by 2 minus 1. So 3 minus 1 by 2. So you get your g value. What is your g value? It is going to be minus 1, 2. Then it is going to be 0, 0. It's going to be 1, 0. And it is going to be 2, 2. Just check. Exactly identical. Isn't it? So therefore f equal to g, right? Because every element is just this. That's how they are equal functions. They are asking us to check the equal functions. This is how we check the equal function, by checking on the points in the domain. This is how equal function. Now we are moving to the question number 6. Where they are giving us a set 1, 2, 3, number of relations that is containing 1, 2 and 1, 3, which are reflexive and symmetric but should not be transitive. It should be reflexive, it should be symmetric, but it should not be transitive. Which is that relation? That relation will be like this. First of all, reflexive. So 1, 1, 2, 2, 3, 3. Right? It should contain 1, 2. It should contain 1, 3. Right? It is symmetric. So it should contain 2, 1. It should contain 3, 1. Only this one. Could we have anything else? No, we'll have only this one. The answer is only 1. We try and we find out any other relation, or it will become transitive. This relation is not transitive. Why it is not transitive? You can take maybe these two elements, 3, 1 and 2, 1. Okay, sorry, not 3, 1 and 2, 1. Maybe you can take what? Okay, 3, 1 and 1, 2. 1, 2. Then 3, 2 should belong, isn't it? 3, 2 is not belonging. If it was transitive, it should have belonged, but it's not belonging. So that is why this is belonging to R and this is not belonging to R. So it is not transitive. Okay, question says that it should be symmetric, it should be reflexive, but it should not be transitive. So when we hunt and find out, we will get only this. Okay, you can look out for others, but somehow it will become transitive, right? It should not be transitive. So there is only one such relation. Okay, next question is identical, where they say that there is a set 1, 2, 3. You have to find out the number of equivalence relations which is containing 1, 2. You have to see how many equivalence relations will have 1, 2. One equivalence relation according to me is, first of all, equivalence. So 1 1, 2 2, 3 3 should be there. It should contain, they say 1 2, because it's equivalence relation, it should be symmetric, so automatically it should contain this. Yeah, this is one relation. Next relation is a relation where all elements are there. No matter what way you take it, you will have otherwise the elements clashing up like that. So here 1 1, 2 2, 3 3, then we'll have all other elements 1 2 2 1, then we can have 1 3 3 1, then we can have 2 3 3 2. That's it. These are the two relations. The answer is B, subpart 2. That's all. No matter whatever you try to take other than this, they will be, they will not be able to become equivalence relations. These are the only two equivalence relations where the relation has to be equivalence and should contain 1 2. The clause is that it should contain 1 2. If it was not there, then we could have found other equivalence relations. So therefore, there are two such relations, right? Okay, then we quickly move to the problem number 17, which says that you have a signum function and you have a greatest integer function. Okay, for these two, you have to check if FOG is equal to GOF on 0 1. You have to check. It's not clear whether it will be, we have to check. So on this interval 0 to 1. So let's check. Consider FOG at x. X is belonging to this interval. So it is f of g of x. Now, g at this interval between 0 to 1, always whatever element is there between 0 and 1, it will definitely go to 0 by greatest integer function. That's how the greatest integer function is defined, for x belonging to this interval. It will go to 0. So g of x is 0 at that interval. So, and f at 0 by definition is 0. Right, that's how the function f signum function is defined. Now we are going to check for GOF of x. GOF of x, that is g of f of x. And that we know, f at this interval in between 0 and 1, that is after 0, because it's an open interval, you don't take 0. So therefore it is after 0, it is going to be defined as 1. Right, x is any value between 0 and 1. It is, so according to signum function, any value between 0 and 1 will lie in this. So the function value will become 1. The function's value is 1 and g at 1. Now when we, for every integer, that itself will be the greatest integer. So it will be 1. So therefore FOG at x is not equal to GOF at x for all these x which is belonging to the interval 0 1, 0 open and 1 closed. So that's about the problem number 17. They ask us to check and we show that they are not equal. We don't know about other intervals, but in this interval it doesn't happen. Now this is quite a technical problem. Number of binary operations on the set AB. If you have a set consisting of n elements, for a set which is consisting of n elements, the number of binary operations, by definition, number of binary operations is n raised to n squared. Okay, so here this n value is 2. So therefore the required number is 2 raised to 2 squared. How much will that come to? 2 squared is 4. So 2 raised to 4, that is 16. Our answer is 16. So that's how the answer comes up. And that's the end of the miscellaneous exercise. We finish the miscellaneous exercise and the chapter with this. In the new video, we come with the new chapter. Thank you.